AES Ohio covers about 6,000 square miles with 527,000 customers spread out in parts or all of 24 counties in west central Ohio. We have a mixed territory that has both metropolitan and a lot of rural areas, and so we are challenged with trying to minimize outages and truck rolls.
AES was really interested in improving the reliability of their distribution grid, focusing on the amount of customers that they'd be able to sectionalize. If there was a fault on the system, how would they be able to isolate the minimal amount of customers?
We decided to have a big initiative to start applying a numerous amount of smart grid reclosers over a 6 to 10 year period. If we have a distribution circuit that we're a third of the way out, you have a fault and you have 4 reclosers on it, and maybe the second one is opened up and you've now stranded 2 sections beyond that. So now we can restore those from another source automatically. We're typically putting up somewhere between 70 and 100 smart grid reclosers per year. So how do we coordinate them? Because it's not just coordinating a single recloser with the upline feeder breaker. Now we have to coordinate 3, 4, 5 devices in series, and how can we make that happen? And then, oh, by the way, we have some large fuses downline that don't coordinate with the ground element.
SEL had recently released the wireless protection system, including the FT50 and the FR12. If we could wirelessly communicate that information that the fault was past the next recloser or past the set of fuses, that upstream control would then know where the fault was and be able to properly coordinate that.
We are using the FT50 RP50 solution in conjunction with the Schweitzer 651R. We are getting those 651Rs shipped to us with the FR12s pre-installed. So the FR12 is the receiver that the FT50 talks back to and then relays that information to the 651R.
We need this tool because we don't have fiber that's talking between the devices. When we have a large fuse that's downline of this recloser and our ground element can't coordinate with it, it will drive it to lockout. So we would want to force that large fuse to operate to blow. Thereby we only have that branch line out, or that phase of that one branch line out, as opposed to maybe 500 or 700 customers, which contributes tremendously to an improved outage statistic. We had a large downline fuse behind a end-of-line recloser on a branch, and then we had an upline recloser in series. So the FT50 at the fuse turned off the ground curve because it wouldn't coordinate, and then the set of FT50s at the downline recloser effectively communicated up to the upline recloser to turn off its fast curve, disable it. And all of that happened in that first 25 milliseconds. And so it all worked together as a system as intended.
The ultimate goal is to roll our smart grid recloser project out to every circuit on the AES Ohio distribution system.
It's been a great experience working with SEL on this project. From the time it was first introduced to us as a product, and we saw a great opportunity for us to use this product, and it has definitely been worthwhile, and we would do this again.